In this presentation, I'll be giving you a general overview of the Utilities module. Starting off, you'll notice that my ribbon is in the traditional user interface, so it may look different to your UI. To change this, you can go to the Support ribbon, and under Options, select whether you're using Light or Traditional. Now back to the Utilities ribbon. The way this is set up is that it works from left to right. So we start by using the Materials and Site Improvement Manager. So in here is where you define utility parts and the materials that we're using on the site. So organize this how you wish, and you'll notice that I have listed my materials: an earthen mass, my backfill, embedment, gravel, bedding, imported material, overlay, and topsoil. Now under Site Improvements, this is where you create your utilities. So I have created 2, and under them I have created my manholes and the pipes that I'll be using in this project. Now moving on, the user defined utility shapes relates to when you create a custom utility in the Materials and Site Improvement Manager. This is so that when you create it in the model, it will generate a CAD object. So the way that the utilities function works is that you create a utility network. This is a combination of your runs or lines. Essentially, it's at the parent level, which can be the sewer, stormwater, or other utility network. Utility run is the lines or runs you have within a network. So if I turn on my sewer design, you will notice that it has 1, 2, and 3 lines or runs. Now utility nodes are defined under networks, and they are the junctions, manholes, or pits within the network. Moving on, you create pipes, and this is used to join the utility nodes together using defined pipes. Now you can create utility lines by converting lines if you have an existing line string defined in your project. This will create utility nodes at the ends of the strings. Moving on, you can edit your utilities, so insert nodes, edit utility run, or reverse the utility run. Now the trenching tab lets you create your trenches for your project and apply them to specific runs. So at the end of this process, you should be able to generate a utility takeoff report. So we will begin by creating our utility network. Since we are using the sewer designs, we're going to create a sewer network. And this type of network is going to be a gravity network. And we're going to put this onto a new layer called sewer network. And click OK. And if you go into your Project Explorer, you should notice that under Utility Networks there is a sewer network. Next, we're going to create our utility run. So if we zoom in, we're going to be using this run, and the name of this is going to be sewer line 1. This is still under the sewer network. Now we can keep this on the same layer as the sewer network, and as defined in our MSI manager, we will put the native material as topsoil. The start station of this will be 0, and we will not be referencing an alignment for this. So once you click apply, you can close this, and you'll notice that there is a sewer line 1 created. So now we'll begin to create a utility node. This is still under the sewer network, and the name of this is going to be MH21. The description, sewer line 1, and we'll put this onto a new layer called sewer pits. Now you can select what type of node this will be, either a head wall, junction box, or manhole. Since we'll be using manhole, we select manhole. And the site improvements, as generated in your MSI manager, will be listed here. Since we've only created a 1050, we'll select that. Now if you select existing, it lets you place a node down, however it won't be calculated in the utility takeoff report. For this, we'll be leaving this blank, and the location of this will be this setup. And now you give it a rim elevation and invert elevation. And if you click apply, you'll now notice that it has created a node there for you. And if you go into your 3D view, you'll notice it has generated a node manhole there for you as well. So I'll continue to create this for these two nodes. Now once that's done, we can now create our pipes. So click into here. This will be under the sewer network, and we will do this under the sewer line 1 run. The elevation types of these pipes will be invert. The end types, so between nodes we will select centerline. So this is the center of pits to center of pits. So the name of this pipe will be sewer pipe 1. We will create a new layer for this one. And you can select what kind of pipe it is, either a circular, rectangular, or user defined. We'll be working with the circular. And the site improvements that you have generated in your MSI manager will be listed here. For this one we will be using the 150 PVC. And this will begin at node MH21 at a inlet elevation of 1. And the ending of this will be at MH31. We can click apply, and you'll notice that there is a pipe generated for us here. Take a look at the 3D view. It has also generated a pipe here. Now I'll repeat the process for this last two nodes. You'll notice that it has begun from where I last finished. So once you have finished creating your pipes and your nodes, you can now create trench templates. If you open up your trench template manager, here's where you can create new, copy, rename, or delete templates. As you can see, I've already created a basic sewer trenching and a sewer trenching template. So looking at these tabs, the basic tab sets up the parameters of the utility part that you'll be working with. You can use the total width, side width, or diameter multipliers. The measurement location that I've selected is from the outside, so this is from outside of the utility. And moving further down, you can set up the minimum width that you will need around utilities. The clearance for this pipe will never be less than 150. You can also do the same with the bottom offset, and with this preview height, you can adjust it to display the height of the trench It does not affect the trench design, is here for visual purposes. The node option down here allows you to adjust the trenching design when the template generates around manholes, junctions or pits. So you can give this width an offset, and if you need more clearance on the bottom, you can add also a bottom offset. So now we'll move to the backfill tab. This is where you define the materials that go in your trench template. The types of materials that you define here will be reflected in the utility takeoff report. So as you can see, I've created 2 layers, a gravel bedding and a backfill. So it starts off with my gravel bedding. The layer start will be at the bottom of the trench. I've selected the thickness as a fixed thickness, which is 0.5 meter, and I'm using the materials that I have defined in my MSI manager gravel bedding. So you can save that. And next I'll go to my backfill. So we want this to go from that gravel bedding layer to the top of the trench. So it will automatically start at the gravel bedding. We select relative height. The top reference points will be the utility run surface, and once we choose our backfill material, we should save that and it should generate it for us. So now we'll move on to the side slopes tab, where you can create your own trench form templates. The way this works is from the bottom up. You can have a very simple trench formation which goes from the bottom of the trench up to existing ground surface. We're going to create a benching trench template. So what we need to do is we need to add an instruction. So we need to go 1.5 meter trench wall. This is not going to be a conditional, so you scroll down and we select in this type box horizontal and vertical offset. So we're not going to offset it to the side, but we are going to offset it up. So 1.5 meters up. We save that and it generates a 1.5 meter wall. The next instruction following on from that one is going to be a 1 meter bench to the left. It's not going to be a conditional, so you go down horizontal and vertical offset, so we are going to go to the left by 1 meter, and we're going to leave the elevation at 0. So we click save and it creates our benching 1 meter to the left. The next thing we'll add is our wall to the original ground, wall to OG. So this is going to be conditional. So when the depth is greater than, we're going to put a small number down, and when it is less than 100 from our original ground surface, this instruction will kick in. So this is going to be a side slope. So the reason I choose side slope is that we can select a ratio or percentage to go up, and it allows us to choose a target surface, which is going to be original ground surface. So we can hit save and it creates a wall up to the original ground. And what you now need to do is hit mirror and it will create our right side for us as well. So the last tab of the trench template manager is the depth zones. This is where you can add a unit cost to the depths of your trenching. So you click add, and by specifying the depths in the box, so I'll put 2 meters, you can add unit costs to it. In order for your utility report to calculate depth zone quantities, you'll need to add in depths here. So 1 is enough for this presentation, so I'll click save and close that. Now after that, we can insert our trench templates. I'm going to go in my plan view and click insert trench template. So the utility run I'm going to be working with is sewer line 1. The chainage or station is going to be at 0. And the template that we were working on is the basic sewer trenching PVC. Now I'm going to click adjust at nodes, which means that the template will form around the nodes. If I unselect it, it's going to form straight through the nodes. So I'm going to check that and I'll click apply. Now it should create a template for you around your utilities, and you can close this window pane. The next thing to do is create your trench surface, and it's going to automatically select your sewer network, sewer line 1. Now we're going to click OK, and it creates our surface for us. You can look at that in the 3D view and see how it's formed. Now the last step is to create your utility takeoff report. Before running this, you'll need to go to the Project Explorer, go to your sewer line properties, and set the target surface to your original ground surface. Once that's done, you can click the utility takeoff report, select the network you'll be working with, and the chainage or station increment at 5 meters, and click OK. So the utility takeoff report generates a report based off the utility network selected. In this tab, the line summary, it shows the node-to-node length and end-to-end length. This will vary if you've chosen to calculate from the inside or outside of the pipe. The next tab, the line takeoff, shows the depth zone quantities, costs, and volumes of materials. So the depth zone quantities show the length of the utility between depth zones, and this relates to the depth zone tab in the trenching template manager. When you look at the earth and mass report columns, this considers only the backfill for the utility line, so this excludes trenching volumes for the manholes, junctions, or pits. In your calculations tab, this is the earthwork volumes. The report shows by chainage cut available, earth displaced, and volumes for the trench fill. If you've selected to adjust the template at nodes, this report considers the trenching volumes around the nodes. The next is this node summary. It shows the different nodes in the utility network and the design total height. And the last tab is the node takeoff. This shows the nodes and their respective site improvements with separate elevations.